Hi guys, my name is Ankit Vashisht and today we will be discussing some best practices to kind of decide or design a software architecture. Okay guys, so let's get started. Best practice. To design a software architecture. Guys, softwares can be of many types. They can be a progressive web app or an Android app or an iOS app or maybe a simple web app, or it can be SaaS and many other things. Because in all these softwares, we have one thing in common, or we can say three things in common. Okay, let me just rub this. In a software, we have a front end, then we have backend, then we have DevOps. So guys, the way we design or the way we connect them, the way we communicate, the way we join everything into one is called a software architecture. Okay guys, let me just rub this. Now, next thing is, what are the communication is done. Okay, so we can say our front end, our back end, and DevOps is kind of single-handedly linked. But the thing is, we have like many factors. Like there are lot of challenges, lot of people, lot of mass. Let's suppose more than 3 million people are kind of entering one big challenge. Then certainly we have like hackers who are kind of using his malicious ways to enter into our software. Then again, UI and UX. Another big challenge is okay guys, and thereafter other big challenges are, one second, let me just write hacker. Some code leaks, that eventually downgrade the software. Lot of codes. There are like lot of codes that make it bulky. Well, there are like many challenges. So basically, all these challenges contribute to destroy performance. Performance of a software. Then it destroys the speed and also accuracy. So now, how to overcome these challenges? Okay guys, so we have like various architectural methods. So in this video, we will be discussing each and every method one by one. Okay guys, so let me just erase this. Methods. To overcome this. Okay guys, so basically some methods to overcome this is BFF architecture. Guys, certainly this architecture is your best friend forever, but in the computer terminology, BFF doesn't mean best friend forever. The real name of BFF is Backend for frontend architecture. This is the real terminology or the real name of BFF architecture. Okay guys, so what is BFF architecture? Let's just discuss this in detail. So basically what happens in BFF architecture, we have a front end. Okay. Then we have a backend. So the challenges is that what we do is we just directly connect our front end with the back end. So the issue is that since we are directly connecting, so any hacker can just intercept once and he can have our backend. So once he can reach our backend, he can take control of our data, and he can do malicious things other as well. And another issue is that since there is just one medium to connect between front end and back end, our code tend to become bulky. Our code become bulky. So to overcome this, we tend to use up the BFF architecture. Okay, so basically what BFF architecture means, so basically we have our front end, then we have our back end, and in between we introduce a new medium. We can say some sort of orchestrator. So basically, front end can now not directly connect with the backend, so it will basically connect via orchestrator, and then orchestrator will connect with the backend. So now the use of this BFF architecture is, now let's suppose a hacker comes, he just gets into front end and he tries to maliciously enter into backend. He will be stopped by an orchestrator. He will get one medium. Okay, this was one thing. Second thing is, we have like multiple environments. We have like dev environment, or we have production environment. We have like QA environment. So the thing is, for all those environments, we can have a different orchestrator. Like we can say that this is an orchestrator for dev. Production will have a different orchestrator, and QA will have different orchestrator. So this will help us introduce multiple environments. So now what we can do is, instead of calling up the backend from single environment, we can just use one orchestrator to simply define which environment to use to call up the backend, and our front end can remain the same. This is one of the biggest factor. I guess you guys are still confused how the orchestrator can help us setting up multiple environments. We will discuss this. Don't worry, we will discuss this. So basically, let's just discuss it how. Okay. So here we have a front end. Okay. The front end is common. It can be common to all environments. Now we have like 3 environments, and each environment has a different backend. So the thing is that we have one backend attached in the dev environment. Then we have one backend attached in the QA environment. then we have one backend attached in the production environment. Now the thing is, what frontend will do is, it will look up just for the orchestrator. Okay, it will just search for an orchestrator. So what will happen is that what orchestrator will do is, frontend will give a comment that, okay, give me the backend for the QA environment. So what orchestrator will do is, it will just go here and it will connect to QA environment. Now, what if a frontend says, okay, give me a production environment? It will connect then to production environment, and it can simply remove the connection from the production environment. Okay, so now one more benefit of a BFF architecture is that this BFF architecture can generate a token. So let's suppose now enters a hacker. What he did is, he just tried to enter the UI orchestrator. The orchestrator, he says that give me production environment, and he tries to get access. So what will happen is, UI orchestrator will ask for a token. If token would match, then certainly the orchestrator can go to disaster management rather than going to some environment. So guys, this is the BFF architecture. Okay guys, now let's just look forward. Now what happens is, let me just run this. Now what happens is that we have like frontend for we can say the app. An app is calling up the backend, and it has an orchestrator. Then again we have the frontend for a website, web FPD. It has its own backend. And it has its own orchestrator. And we have like multiple apps, multiple web apps. We have like, we have backend frontend orchestrator for an app. We have like backend frontend orchestrator for a web. We have like backend frontend orchestrator for a, we can say, for a voice AI or something. So guys, we have like so much things, so many things, and what happens is that using these many things, we have like backend deployed like, we can say 100 times. We have frontend deployed like 100 times. we have orchestrated deployed like 100 times. So basically, again, our code tend to become bulky. So to overcome this problem, what as an architect we do is we make use of something that is called headless architecture. Guys, this architecture has been used in multiple companies, in all the big companies. Okay, so basically, what headless architecture is, we came to know that all apps, progressive web apps, backend, all apps, progressive web apps, iOS apps, voices, everything is calling up same type of APIs. So what we can do is we can reuse our code and we can just define us one single backend and one single orchestrator and what we can do is we can make up multiple front ends. Let's suppose for an app we have this front end, for a web we have like this front end, and what it will do is it will call up the same. So basically it will call up the same orchestrator and backend via use of, we can say, the APIs. Now, instead of having like multiple orchestrators and multiple backends, we can have one single API that will be calling up the orchestrator or a single backend which is common. So it's like a head. We can keep frontend over this. If we are using app, we can keep frontend of web over this if we are using a web. So what will happen is that this will make our code less bulky. So guys, that's all for this video. Please make sure to like, share and comment. Thank you guys. Have a nice day. Bye.